Okay. So, hello everyone. But before I start this talk, I actually want to know how many of you actually have used Prisiac. Oh, that's a good answer. That's a good thing to know. So today I'm going to tell you about one of the challenges that we faced in Prisiac and how we navigated through these challenges. It's not going to be a talk mostly about like a complicated model that you deploy. It's going to be a talk about how you look at not just the modeling side, but also looking at the data aspect of things as well. So let's start with this. Um, Before I actually move forward with what we did, what we started with, I want to take like a zoom out of everything. So in Prisiac's context, there are different jargons or different ways that we define something. So for example, for us, there are multiple things like what is a product, what is an offer, what is offer categorization. So you have this I wrote like a really big title of it, navigating the challenges of offer categorization in e-commerce. Like I'm pretty sure like most people in e-commerce might know about it, but I'm guessing like most people around, like most people would not be familiar with these terms. So I'm gonna actually define each aspect of it, and then I'm going to move forward to what was the actual challenge, and how we moved forward with it. What were the what were the challenges we faced, and how we actually approached them and dealt with them. So let's start with what is a product in context of Prisiac. So a product is something, anything tangible that is unique for Prisiac. So for example, if you see in the screen a product, PS5 is a product. So that's like a unique product. So for example, PS4 could be a product. Or if you take like things in different other categories, like you have like a Nike Predator N90 something shoe. And that's also a product. So product is something tangible that you can actually buy on Prisiac. So that is what a product is. Okay. Now getting back to offer. So what is an offer if the product is something tangible? So offer is something that different marketplaces or different websites actually send us data about that particular product. So on the previous slide, you saw that PlayStation 5 is a product, but different websites, for example, in this case, CDON sends us information about that product. So that information about that product, so that information could be the actual text, it could be EAN codes, it could be delivery time, it could be the actual price. But here we actually, I think everybody just looks at the price. So that's what's important here. So we have like different stores sending in information about that particular product. But the most important challenge here is that, okay, it's just string matching at the end of the day, right? But what would happen if there are like 100 million offers and you have 10 millions of products? How would you actually map them, cluster them? And that's where the point of offer categorization comes in. So what is offer categorization? So offer categorization is the grouping or categorizing of these offers that the shop sent us into particular categories. So these are mostly hierarchical categories. So if you look here, it's like PlayStation is inside like ham, and then gaming and something complicated in Swedish, and then it is spelkonsoler. I hope I didn't butcher it. Spelkonsoler, yeah, let's move with that. But I know that it means gaming consoles, right? So if you see here, I took this exact screenshot from Prisiac's website. So PlayStation 5 is a product, and the offers are like these two offers. There are multiple offers for each product. There could be like 100, there could be like 10, it could be like a single offer. So these are the offers. This is the product, and the category is actually like spelkonsoler in that case. So why do we need offer categorization? I gave you like a general overview, and I didn't go into detail, but it actually helps with a lot of things. The first thing is search relevance. So how does this help with that? So for example, you search something on Prisiac's website, and you come across the first result. So that's okay, that's string matching. You actually maybe use some Elasticsearch or something like that. But maybe you want to recommend something to a particular user that is maybe closer to the product that they're searching, so maybe they could want to buy that also. So that's where the categorization helps, because if you know the product that they're searching, you can actually get that category and then map it and like narrow down the space that you want to search for. Product matching. I think I mentioned it earlier, but product matching is like mapping those offers that the shop sends us to those particular products. So product is something that we create ourselves. So for example, PlayStation 5, but matching those particular offers to a particular product, that's a really complicated task, especially if the shops send you just a price and a text. It's easier when they send us like EN codes, because you can just match the EN code, and like different products have different EN codes, but EN code is usually unique. So you can do that. But when you actually have millions of offers and tens of millions of products, this becomes a really, really hard problem. So what you do is you categorize the offers first, and then it narrows down the space. Now the product matching becomes an easier thing. You actually create the same way that you're doing product matching. You can actually create new products out of it, because once you have categorized offers into products, you can actually offers into different categories. You can actually end up like creating brand new products out of it. So similar products might have similar text, they have similar images. So that is something that it can help with as well. It can also help with SEO. So SEO in that aspect, that Google gives you like a really better score, or like if you search something on Google like iPhone 14, and if you want your result to be on the top page, the most probably if you have like categorized it to a particular taxonomy, Google ranks you better. Extraction of attributes from the products. So it can also help you extract attributes. So attributes could be color, it could be size of shoes and everything. So for example, the attributes for shoes might be different from attributes for PS5 maybe, because PS5 might not have like something size. It could simply have a color, or it could have like a RAM, but a shoes cannot have a RAM. So yeah, I hope you get the context. But offer categorization, there are so many things when you actually start thinking about offer categorization. Yeah, it's just basic classification. Not as simple as that. So when you think about offer categorization, there are a lot of things that come to your mind. So for example, where do you start with offer categorization? Like what data to use? So there are a lot of things that the shops send us. Some shops send us good data, some shops send us like bad data. Do we already have labeled data? How do you actually like map the problem? Do we have some sort of feedback loop? Do we train the model like one time, and that's the end of it? Do you do like some sort of automated training pipelines? What are the metrics for this evaluation? And the most important question, where do you actually get the categories that you want to classify to? Because if you classify to, for example, a generic category like PlayStation is inside just games, are like PlayStation games gonna be in the same category? Isn't it making problems like more complicated for yourself? So that's where the hierarchical part comes in. Finding list of categories, I think the biggest challenge that we actually faced in the beginning was finding list of categories. Where do you actually get that? So if you see that the market is constantly changing, there are always new products, new stuff going on, market trends, somebody comes up with something new, right? So how do you come up with your categories? The basic thing that you can do is you use your own category. But as you deal with like millions of offers and millions of products, this becomes quite complicated to like, if a new category comes in, where does it lie? How do you keep track of it? So for example, I've given it like an example here, like cat food. Where does it lie? Is it lie in food, like human food, or is it part of something else? Do you make like a animal food category and inside you made cat food, and like how do you distribute them? So it becomes complicated quite fast. The solution. So Google has something called Google taxonomy, where they have these hierarchical categories, and it's based on market trends, it's based on the products that are created. So they have nearly 6,000 hierarchical categories, and they're constantly evolving those categories. And then It's maintained by Google, but we didn't want to rely just on that. So we took like a base level Google taxonomy, and we built our own version on top of that, so that if Google changes something major, we don't have to keep track of it, and we don't like cause problems in our system. So it was kind of independent from that. So this is what a Google taxonomy looks like. This is just one example. So apparel and accessories, it has a child, which is clothing. And inside clothing, there are suits. And inside suits, there are pantsuits and skirt suits. So you see, it's an offer that's categorized into pantsuits. When you think about it, product matching becomes easier. The search becomes easier. Creating new products becomes easier, because if it was just classified to clothing, it would have like combined like pantsuits and skirt suits or some other suits that are there. So what data did we have for offer categorization? So for the labeling part, label for that which we were like kind of classifying against was the PrisCheck's internal category. So that category is, as I mentioned, built on top of the Google taxonomy. It had like a category name. This was our internal name, which is like media books. We have like a price, which is like the actual price that shops send us. The product image. So shops send us various things, and one of these things is like images for that particular product, the product name, the text that they actually send us. And the interesting thing is that every shops for the same product sends a totally different text. And that's what's the interesting part. For example, I'm gonna interestingly, like for PS5, somebody's gonna write PS5. Somebody's gonna write PlayStation 5. Somebody's gonna write PlayStation 5 new, very expensive, and stuff like that. PlayStation 5 something model. So it's nothing concrete. It's not like, okay, just like do simple string matching or just like fuzzy algorithm and that's it, you're done with it. They don't want to make this easier for us. And the last thing that we use is stores internal category. So when stores, so we are like an e-commerce website, so when Web Holland and all of these shops, they want to categorize it, so they also assign their internal categories to it, which is interesting. But that is something that they send us. So for example, they have like a generic category for most of the stuff. So for example, for suits, they might have just like clothing, and that would be it for the category. We have different sources for our training data. So we have mapped the categories, we have the data that we want to train on, but we actually, now we want to start looking at the data that we have like from different sources. The first source was that we had like an old PrisCheck category that you see actually on the website as well. We started like creating mappings from that to the Google taxonomy, our Google taxonomy version. The second thing was the Google category sent in by the stores. Now the stores also, some of the stores also classified the Google taxonomy. And we were like, yes, it makes our job so much easier. They are gonna be the savior for us, blah, blah, blah. And third was the categories that were labeled by our annotation team. I'm going to quickly wrap this up because I don't have enough time. We did some basic data cleaning. We didn't want to make anything complicated because we want to make it as simple as possible. We removed all the dummy data. So for example, some sites even send in like in the text random HTTP links, random text, like random characters, unreadable characters. So we actually removed everything. And in some of the store categories, funnily enough, some stores sent us a category called for example, for books, they sent a category, so they had to send in a category. So some of the stores, interestingly, sent us secret category for everything. That was like, we found out, we did a lot of analysis, and we found out this was one of the things that they did. But for the classification problem, how do we actually go around it? So it could be like a simple classification problem where we do like simple flat classification. So we have around 6,000 categories. We just assign a category to each of the offer, and then it's as simple as that. But there's a little bit of problem with it. When you do flat classification, to some extent, you lose the hierarchical structure. So if you go deep into the category, for example, pantsuit, but if it's wrong, it's gonna categorize to some random category. And if it's not sure, that's what we get like a lot of false positives. The second way to go about this was like create each model per node. So if you think of like the hierarchical structure, so if we create like a model for every single category, so it ended up like 6,000 models. Yeah, not scalable. The third part was the model output per level. So that was something interesting. So you see, like in the previous slides, we showed this like Google taxonomy, like there was clothing and then suits and then suits, pants, skirt suits, right? So for each level, you create a separate model, and then you actually predict each level for each model, and then you kind of combine these results. So you get around like maybe 6 models. But we took a different approach. What we did was we wanted to have like a single model that is going to output 6 levels at the same time. That way, it's easy to scale, it's less costly, you don't have to go through like 6 different models to get through the solution. It's one model responsible for all the 6 layers. And that's what we did. So for a single input that we get, we actually get like 6 outputs from level 2. We don't want to make it like through the root level, like arts and entertainment in this case. We started from level 2, and then we went all the way to the leaf level. Now let's get to the best part. I guess everybody wants to wait for like the algorithm and the modeling part. That's what everyone wants to be doing, because that's us machine learning engineers. We want to try out all the best models, all the BERT models, and be really cool that we actually did something like that. But for us, we had limitations. We had latency issues. We wanted to keep it below a particular threshold. And we also wanted to not use GPU for actually inferences. So that was the challenge that we faced. So we had to take a step back. So we started looking at some simpler models, maybe. We actually started like a simple baseline where we create like embeddings for like 3 different inputs. It was for store category, for input, and then for price. And then we just trained like embeddings on for each of them. And then we had like a dense layer, and we produced like 6 different outputs. That was it. But when we tried like these different models, we actually didn't get a good score. We had like a score of like 67% accuracy. We were not like satisfied with it mostly. And even with like trying these BERT models and stuff, we weren't actually able to get like an accuracy to a point where we can see like, oh, maybe BERTs and Electra or Roberta is really worth it. So what now? How do we move forward with it? We started doing analysis. So we started looking at data more deeply. So it's like 100 millions of data points. So the analysis takes a lot of time. I'm not going to discuss it here. But we started like separating those cases where the labeling was really bad. And lo and behold, shops that were doing the Google taxonomy were actually doing it really badly. So they were sending us bad data altogether. So we were actually using that data for our model. So at the end of the day, we were providing it garbage, and it was giving us garbage. So that was more or less the main issue with the model, that it was not getting the correct labels that we were trying to classify as against. We removed those, and we started updating our training data. And we got a better result. We got much better results. We got like an 85% accuracy, which was a huge bump from the 67%. Model training, as I mentioned, after pre-processing, we had 3 inputs: the product name, the offer title provided us by the store, the price, and the store's internal category, not the taxonomy that they provide us. So we pre-trained like Gov embeddings. We took like pre-trained Gov embeddings. We applied it on each input separately. Embeddings were made trainable, so they can actually learn which words are closer to each other. So suits are closer to pantsuits or some other suits rather than to PS5. Prices were bucketed and added like as a categorical feature, so the model can maybe learn like shoes are in this range, or some other category, or some other factor for some other product is in that particular range. Metrics, we did like precision, recall, and F1 score for the model validation, but I just wanted to get to something really quickly. We actually did something really interesting. So the reason for keeping the hierarchical structure and keeping that intact was that we actually wanted to penalize a model when the levels differ. So for example, if electronics audio was the second level, the third level, if it changes to maybe electronics something else, it means that the model is learning something different and the data is bad, or the model is learning the wrong thing about the data. The second evaluation we did was we didn't want to stop there, and I think we wanted to focus really on the evaluation part. So after the model was trained, we actually had like 4 different criteria. One was if the model is correctly predicting, and we assign like weights to it. The corrector prediction, in which the actual prediction and the label, they match. The second was too general prediction, in which, for example, the actual label was like in depth to level like leaf level, but the model actually predicted higher up in the category. The third thing was too specialized. The label was something level 3, but the model actually predicted something at level 6, and the wrong category, in which the model was totally wrong. So we assigned different values to it, different weights to it based on some heuristics. And the final part. The final part was how did we do level selection? The level selection we did was we started from level 6, leaf level. So we had these thresholds defined at each level. For example, at level 6, it's greater than a particular threshold, we actually select that. If it's not, we move up to level 5. And we keep on doing that until we select the level 2. Yeah, I'm really above time, but I'm going to go through this really quickly. So our setup was that we really focused on the data annotation and the data labeling aspect and data analysis part of it. We didn't just want to try out, we didn't just like want to go with like the cooler models and like trying out different things. Just last notes, it's not all about the model, it's about the data. If you focus more on the data, the simple model can still give you good results if you know where to look. You should focus on, is your labeling data correct? Where is the source of data? If your source of data is coming from some third-party location, how you can make it better by having a continuous discussion with them. If you have an ingestion team, have a chat with them, how they're getting the data. And at the end of the day, if you're going to provide garbage, it's going to give you garbage. Thank you.
Thank you. Do we have any questions from the audience? So, so what were the consequences of you predicting the wrong classification? How would that show up in the web page?
So we actually don't use that or on our web page in that aspect. So what we did was it was actually mostly used for product matching. So if you actually ended up like putting it in the wrong category, so the product matching would not, for example, the product that was created in that category won't match to that. So it will never be categorized to that particular product.
And if you search for PS5, it would not show, the offer would not have shown
exactly.
up there. Okay, cool. So have you thought about using like large language models just directly on the product description to cluster the products or the offers instead of doing this classification beforehand?
Yes, we actually tried that, and we ended up getting like a lot of false positive, and that's mostly related to how shops send us the data. So it ends up like being, for example, just sometimes the shops send us like just Nike shoes. It could be a lot of things, and they ended up categorizing into the wrong category. Or for example, if it's something related to, I don't know, Zelda game, right? Or some Zelda product, it ended up categorizing it to that particular. So we ended up getting a lot of more false positives.
Right. The model ends up almost being a data validation tool in that sense.
Yes.
Okay. Okay. Thank you.